10.4. Use inscribed angles and polygons. Essential question. How do you find the measure of an inscribed angle? Well, we know how to find the measure of an angle. We just have to figure out what an inscribed angle looks like. So let's do some vocab here. Remember an inscribed triangle? That was a triangle that was inside a circle per se. So if I have a point here, a vertex point here, and a vertex point here, and kind of using chords now to connect, that's an inscribed triangle. Opposite angles. Now opposite angles, remember, if I have a quadrilateral, these angles are opposite one another. So this angle is opposite of that. So that means kind of across from each other. These angles here would be opposites as well. So opposite angles, angles across from each other. An inscribed angle. An inscribed angle really looks like this. Again, an inscribed angle refers to a triangular situation, or actually a circular situation. And here's an example of an inscribed angle. So it appears as though the vertex of the angle is on the circle, and that the sides of the angle are actual chords, or secants that contain chords. So how can we describe an inscribed angle? It's really an angle of a circle with its vertex on the circle. Alrighty. Now the intercepted arc is an arc that is formed or separated from the circle via an angle. So right here, from here to here, that's our intercepted arc. So it's an arc formed by the sides of an angle. So some terminology here. So what's an inscribed angle here? If I have this angle, what does this give me? I'll put 2 question marks there. Now moving on here, we have a theorem and some practice here. The measure of an inscribed angle is half the measure of its intercepted arc. So again, kind of a generic way to look at this, if I have this, and this is x degrees, this is 2x degrees. If I have this situation here, okay, if this is 110 degrees here, this is 55, because 1/2 of 110 equals 55. That's where that comes from. So now with this in mind, let's go ahead and work on this A1 problem here. To sketch or find the following here: an inscribed angle AB or ACB with a measure of 50 degrees. So if I'm going to go ahead here, that could be 50 degrees. So if I go A, C, and B, this is 50 degrees. Now right away I know that this is 100 degrees. Arc DB with a measure of 34. So DB, I'm going to go ahead here and put D here, and this is 34 degrees from here to here. Chord CD. Chord CD. Okay, that wasn't too bad. Inscribed quadrilateral CABE. So CAB, and I'm going to put E right here. E could be anywhere between B and C. So I'm going to go ahead and trace this. So there's an inscribed quadrilateral, like an inscribed triangle. The arc of AB, I already have that. That was something I found right away. AB, 100 degrees, so I'm going to write it here as well. And the measure of angle, DCB. So now this angle here is going to be 1/2 of 34. So this happens to be 17 degrees right here. Okay. So just some work with our new terminology and our new theorem here. A little too quick here. Let's go ahead here a little bit more. Okay, typical problem here is A2, find the measure of G, angle G. So here's the inscribed angle. This will be 1/2 of 90 degrees, 45 degrees. The measure of arc HGF. So HGF is going to be 360 minus that 90, 270 degrees. So that's that. And the measure of angle G was 45 degrees. Okay. Now let's move forward. An additional theorem here. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. What does that look like? I've got a circle. I've got this intercepting this arc here. And if I've got this angle intercepting this arc here as well, then this angle must be congruent to that because half of an amount is the same all the time. So let's put this to use in A3. Find the measure of arc RS. It's right here, formed by this angle, times 2 is 62. So 62 degrees. Angle STR does in fact intercept the same arc. So this is going to be 31 degrees because, well, theorem 10A. That's just a shortcut. So 31 degrees. All right. Theorem and a practice here. An inscribed angle is a right angle if and only if the angle intercepts a, if you think about it, if I get a 90-degree angle here, that means this is 180 degrees, which means it's how much of a circle? It's half the circle. So that means this would have to be the diameter, and the intercepts a half a circle, or otherwise known as a semicircle. Okay. So here's a diameter. Here's 180. So this angle here is 1/2 of 180. So this is 90 degrees. Okay. If I wanted to know, I could find this by 180 minus 90 minus 50. This would be 40. Oh, 40. Okay, let's just back that up. This would be 40 degrees. So what is the measure of angle CAB? 90 degrees. Another theorem and some practice problems here. A quadrilateral can be inscribed in a circle if and only if its opposite angles are. And now if I go ahead here and picture this, I've got 1, 2, 3, and 4. Okay. Now, this angle is part of the circle, and this angle here is the rest of the circle. So 1/2 of 360 is going to be 180 degrees. And two angles that add up to 180, they are considered to be supplementary or supplements. Okay. So now here we have an inscribed quadrilateral. So that means these two guys, y plus 104, has to equal 180. So y has to equal 76. Likewise, these two have to add up to 180. So that means x has to be 112 degrees. All right. Problem B here. Let's see, this angle x is all of that. So x equals 1/2 of 170 plus 40, which is 1/2 of 210, which is 1/2 of 1/2 is 105. So now since this is 105 degrees, we now can say that x plus y has to be 180. So x plus y equals 180. X is 105. Subtract that over and we get 75. We get 75. All right. Finally, the last couple problems are kind of off the A type of problems, so we are done with our lesson.